Hello, in this video I will show you how to extract information from an IFC file using Python. In this video I will start by showing you how to install the IfcOpenShell library, how to view an IFC file using BimVision, and finally how to extract the information from the IFC file. Let's start with the first step. To install the library, go to this website. It's called IfcOpenShell. The link can be found in the description. Here you have many options to install the library. So click on Downloads. Here, as you can see, you can install it for C++ or Python. In this video, I'm going to look at Python. So click on this Download button. And as you can see, here we have a lot of options to install the IfcOpenShell library. In this video, I will use PyPy to install this library. I will create a new Google Colab project and I will paste the command that I copied from the documentation. So basically, we are using pip to install the IfcOpenShell. I hope that you haven't received any errors while trying to install the library using pip. If this is the case, then let's move to the second step. Navigate to this website. It is called BimVision. One more time, the link is in the description. Once here, go to the Download tab and click on BimVision. Enter your email address and click on Send. Now, find the message that you received in your email address and click on the link to download the software. I have already done that and this is how it looks like. To view an IFC file, click on this folder icon. I will choose this one as an example. As you can see, when I did that, the model was loaded successfully. And now I can click on a wall, for example. Let's take this wall as an example. I can click on it and look at its properties. You can see that it is an IFC wall. Here we can go to this location tab to get for example, the elevation, the position of this wall, the bounding box, the area, the volume, etc. This is exactly what we want to get, but by using Python instead of the BimVision software or any other software that lets us open the IFC file. Let's move back to our Colab and let's continue working on this program. First, I will import Drive because I have the files on my Google Drive. But if you are running this locally, you don't need to add this. Good, this is done. Let's add a new cell and import the library we installed earlier. Here we are printing the version just to make sure that it is working. Good. Don't pay attention at this. We can install lark, but we don't need it. Here we are also importing geometry and shape because we are going to use them later when we want to get the area of a wall, for example. To read an IFC file, we can use the open method. To do that, let's add a new cell. Here I am specifying the file path. You can see that hey, this is the IFC file and it exists on my Google Drive. This is why I have added or imported Drive, as I said. But if you are running this locally, make sure to change this path. If I run this cell, it should work without any problems. Good. Now we have seen that when I click on this wall and let's click on properties, you can see that it is of type IFC wall. So to get all the walls, we can use this. So we can get the file or the object that represents the IFC file or that stores all the information present in that file. And we can get all the IFC walls just by using the bytype method. Okay, so here I can do, to show you, I can print the name of each one of these walls, just like this. You can see that these are all the walls that I have in this IFC file. But in our example, we want to select just this one. So go to this properties and you can see that we can get the GUID. So this is an ID that you can take and compare. So here I can, for example, get the global ID like this. Here I have made a typo. Instead of global, I need to make it global ID. Okay, so you can see that we are getting the global ID. And now instead of printing that, I will just add this condition. So let's test if the global ID equals this wall's global ID. So now let me just print this to see if this is working. Wall.name. Okay, everything is good. So now inside this condition, we are getting this exact wall. Now we are going to use this geometry and all the things that we have imported. So remove this line because we don't need it. And here I am going to get the shape of this wall. To get the shape, we are using, let me just remove this white space. We are using settings, and this method create shape will take the wall and it will give us the shape. Using this shape object, we can extract all kinds of information. For example, we can start with the area. You can see that we are using this shape object to get the geometry, and we are passing it to the get area method to get the area in meter squared. And here we are rounding the value just to get to decimal places. To get the volume, it's very easy. Instead of using the get area method, we use the get volume method. Let's print this. Okay, you can see that this wall has a volume equivalent to 58 meter cubed. To get the wall's position, we are using the getX, getY, and getZ methods. Let's print this. Good, this is working. Let's continue. To get the height of the wall, we use the getTop elevation. You can see that this gives us 24 meters. And finally, I will just end this by showing you how to extract the parameter by using getFootprint parameter. Now, let's verify to see if these values are the same. Let's open BimVision. We have this wall selected. This is good. Let's compare the values. Okay, so I have both Colab and BimVision here side by side, and let's see. Let's click on location and let's start by looking at the area. So you can see that the total area is equal to 549, which is the same. Good. The volume is 58.75. That's good. Let's look at the XYZ positions. We can see that these values are not the same. That's because here we have global X, global Y, and global Z, which means that these values are in the global coordinate system. But here in the script we have X, Y, and Z. I think these values are coming from the local coordinate system. But looking at the height, this is the same value. You can see that here we have 24.67, and finally the parameter is equal to 22.5 meters. I don't think we have this value here. But here I have showed you just few things, but you can do a lot more with this library. You can visit their documentation to see the examples they are providing to learn more. Thank you for watching.